Good morning to all. I am Lalita from the Department of CSE C section. Today my topic is band theory of solids. What is band theory? Band theory states that in solids, closely spaced energy level of atoms combine to form continuous bands of energy which determine the electrical conductivity of the material. This is structure of the band theory: condension band, valence band and band gap. Electron orbital are stable only when the orbital length is a multiple integer of the electron wavelength. The right hand figure shows an electron orbital with a length 4 times the electron wavelength, 2 into n into or equal to n into lambda. Band diagram for conductors. According to band theory in conductors, the valence band and condension band overlap each other. Because of this overlap, electrons can move freely from the valence band to the condension band, allowing easy flow of electric current. Band diagram for conductors, condension band, valence band and conductors. If a solid is conductor, it has either partially filled or completely filled valence band overlapping with condension band. When a potential is applied across the solid, some of the electrons like to the condension band and hence it acts as a conductor. The forbidden gap is not present in good conductors. The electrical conductivity of a metal decreases with rise in temperature because increased thermal vibration of the atoms cause scattering of the electrons, thereby obstructing their free flow. Band diagram for semiconductor. The band theory of solids explains electrical conductivity by categorizing material into conductors, semiconductors and insulators based on their electron energy bands. For a semiconductor, band diagram for semiconductor: valence band, condension band, band gap, e.g. less than 3 electron volt. If a solid is semiconductor, it has an almost filled valence band, empty condension band and a very narrow energy gap at 0 degree Kelvin. All semiconductors are insulator. As the temperature increases, the width of the forbidden gap decreases. Hence, some of the electrons jump into the condension band. So, the electrical conduction of a semiconductor increases with rise in temperature. Band diagram for insulator. A band diagram of an insulator is a representation of its electronic energy bands, showing a completely full valence band separated from an empty condension band by a large band gap. Band diagram for insulators: valence band, condension band, band gap, e.g. greater than 3 electron volt. If a solid is insulator, the valence band electrons are tightly bound to their nuclei and require a very large electrical field to remove them are called insulators. For example, diamond 6 electron volt, glass 10 electron volt, etc. At room temperature, there is no change for electrons in the valence bond to jump into the condension band. Hence, those substances show the best insulating properties at room temperature. However, at higher temperature, some of the valence band electrons jump into the condension band. Hence, the insulators exhibit and conductivity with rise in temperature. Advantages: explains why materials or conductors, semiconductors or insulators. Second, helps understand temperature effect on conductivity. Third, useful in designing electronic devices. Disadvantages: assumes perfect crystals, not realistic. Second, not accurate for complexes or impure materials. Third, does not explain magnetic properties well. Thank you.